Can you all see my screen? You can ping in chat. Okay, good. So, like array basics, right? Basically, if you want to create some arrays, first thing you need to do is import this library numpy. So import numpy. Okay. So once you import numpy, so let's execute. Okay. We can create a array like this is a name that I have given. You can give as your own choice, like my array or whatever, right? A new array something. It's equal to numpy. So this library numpy dot array. Okay, and then you need to write the elements inside the list, like say 1, 2, 3, 4, 5, right? And then we are printing error. So what's this? So first of all, we are going to create an array, okay, one dimensional array, and then we are going to store it in ARR, and we are going to print ARR. So 1, 2, 3, 4, 5. So though it looks like a list, but it's an array. Okay. Now, like you can directly import libraries like this, import numpy. So remember one thing here, I needed to use numpy, the, the whole word. Okay. In Python, the standard is like we can import the libraries using some aliases. Okay. So like importing numpy with alias np. Now, someone of you can ask me like, can we use different name? Yes, you can use different names also, but it's a standard in Python that we give np name for numpy, pd for pandas, okay, etc. Matplotlib.pyplot as plt, like this. So import numpy as np. What it does is it imports numpy library and assigns to np. So we need to just call np.array, not full word. Let's see how it works. Okay, so now we can do the same thing as above, like array equal to. Now I do not need to mention the whole word numpy since it is already imported in np. So np.array 1, 2, 3, 4, 5 print error 1, 2, 3, 4, 5. Right. So np works if we import the numpy library as alias np. Now suppose you all may have different np versions, numpy versions installed in your system. Okay. So how to check the version of the library? So print np dot underscore underscore version underscore underscore. This gives you the current version. Okay. Like in Google Colab, this is the version installed 1.19.5 of NumPy. Right? Now, let's say to check the data type of the array, what we are going to do is we're going to create the array 1, 2, 3, 4, 5 print and then print type of array. So this prints the type of the array. So class numpy.nd array. This means numpy n dimensional array. Here n equal to 1 dimensional array. I'll talk about it like what is 2-dimensional array, what is 3-dimensional array, etc. Okay. Now so far you see that we have used list elements to create the array. We can use tuple elements also to create the array. Okay, same way like import numpy as np, array equal to np dot array of this tuple elements 1, 2, 3, 4, 5 and print array. This will give you the same array. Okay, right? So far clear, right?
Yes.
Okay. Okay, so what is the difference between list and array? Okay, so see, list is always one dimensional, right? List is always like this, one dimensional. But array is like it could be multi-dimensional. It has rows and columns also. So basically, array we use for data storage. Okay, list we use for variable storage primarily. So these are the primary difference between list and array. Okay. Now say how to check array dimensions. Okay. So like if I want to create a 0-dimensional array, what is 0 dimension? 0 dimension means a constant element, a single element. Okay, so import on numpy as np, array equal to np dot array, or just a single element. If I print it, it will be printing 50. So this is a zero dimensional array. Why array? Because I have defined np dot array of 50. That's why it's array. Now, one dimensional array, you already know it. That's why I'm not repeating. This is 1D array. And what is 2D array? 2D array is like it will be having two dimension. Like say rows also it will have, columns also it will have. So rows cross columns. So import numpy as np, array equal to np dot array. So there are two lists, and then this is one list, this is another list, and then list of lists. So this is the list, right? So how it treats numpy treats is, this is the first row and this is the second row. So print array 1 to 3. This list is the first row and this list is the second row. That's why it has x dimension also, y dimension also. So this is 2-dimensional. Okay. Now let's say we're going to create a 3-dimensional array. Okay. 3-dimensional array, what it will have is, it will have, see, what we are going to do is, this is a list, this is a list, right? This is a list. Sorry, this one. So this is a 2D array, right? Again, we are going to define a 2D array. This is one 2D array, and this is second 2D array. And this entire list, the final list, entire list of two 2D arrays, if we define like this, an np dot array, that becomes a 3-dimensional array. I'll show you how. So why 3-dimension? It has 3 dimension because this is the first matrix, this is the second matrix. So m cross n cross p kind of. Okay. So this is first matrix, this is second matrix. First matrix, it has 2 dimensions. Second matrix also 2 dimensions. So this becomes a 3-dimensional array, like row, column, and the position of first matrix, position of second matrix, and so on. Right? Index of first matrix, index of second matrix. So 3 dimensions. Once you create these arrays, a 0-dimensional array, 1-dimensional array, 2-dimensional array, 3-dimensional array. Now to check that whether these are really 0D, 1D, 2D, or 3D, let's check. So I'm going to create, like say, import numpy as np. Remember, so you might be seeing me that calling this function repeatedly. This is not required, since sometimes I run codes randomly. That's why import numpy as np need to specify before executing this np dot array. But otherwise, as per the Python standard, you just define at the start of beginning of the code. Okay, that's one time call for all the libraries, required libraries, and then you can start coding as you proceed move forward. Okay, so a equal to np dot array 42, b equal to np dot array, this is 1D array, c equal to np dot array, this is 2D array, d equal to, this is a 3D array. So now if I print a dot ending, okay, so what it does, n-dimensional means it prints the dimension of, I mean, a, b, c, d. So print b dot ending, print c dot ending, print d dot ending. Let's see how many dimensions it has. A has 0 dimension because it's a constant element. B has 1 dimension because it's a 1D array. C has 2 dimension because it is 2D array, and D has 3 dimension, I mean 3D array, because it's a 3D array. N dimension equal to 3 because it is a 3D array, right? So I see a chat. Okay. So hope it's clear, like different dimensions for these 4 matrices. Now let's say we can create a higher dimensional matrix also. Okay, higher dimensional matrix, like say 5D array. How can we create it? So this you know, I'm not repeating. Error equal to np dot array. So this single list, but dimension is 5. N dimension equal to 5. So what will happen is, okay, the other dimensions will be blank. Like say, if we print array and print number of dimensions array dot ending, right? Let's see what it. So like 1, 2, 3, 4, 5. Okay, 5 dimensions, like 5 lists. Okay, and final element is 1, 2, 3, 4. But if you check the dimension, it is 5. That's why it is 5D array forcefully. I mean, it's a one list of elements, but forcefully we are making it 5 dimensions. So this becomes 5D array. So generally we don't require 3D array, 4D array, 5D array. 3D array sometimes may be required, not more than that. So till 3D we may require, and 2D is always we require. 2D is for statistical data, tabulated data. Okay, like okay, 2D is for statistical data, like we store in rows and columns, like so. Okay, good. Now say array indexing. So accessing array elements like list, tuple, set, dictionary, you can access, right? Similarly, and obviously we need to access elements from array because we want to understand like what data we have stored, and sometimes we need to make some operations, right? So let's see how to do that. Array equal to np dot array. This array we are going to create. Now, can anyone of you tell me like, so print error 2, what will be the value? Or say print error say 1, what will be the value? Anyone? I mean, who does not know Python?
21.
21, right? Because this is 1D array. Remember, this is 1D array. That's why I need to pass only one. I'll show you one by one. You will understand. If it is 2D array, I needed to pass two elements and two parameters. If it is 3D array, I needed to pass three parameters. So print array of one index 0, 1. So 0 index is 10, one index is 21. So it prints 21. Okay. Okay, so I have already done that. So let's say print third element. Third element means index 2. Remember, index uh, plus 1 is the position of the element. So 2 index means 0, 1, 2. So third position. So it will give you 3 for this array, right? Okay. And how to access the third and fourth elements? And you can add, right? So third and fourth element means array 2 plus array 3, print it. So directly we are adding the values, and it will print 7 because array 2 is 0, 1, 2, 3, and 0, 1, 2, 3. Array 3 means 4. So 3 plus 4 equal to 7. Right? Now that's how you can access elements for 1D array. Now how to access element for 2D array? Let's create a 2D array. Array np dot array 1, 2, 3, 4, 5, comma 6, 7, 8, 9, 10, print array. And say I want to like say, so array 0, 1, as I mentioned, like I need to pass two parameters for 2D arrays because this is for row, this is for column, this is for row, this is for column. So let's see. Basically 0, 1 means, so this will be rows, right? So this is the 0th row. Okay. Okay. Remember here, I mentioned in terms of list, tuple, those things, but in terms of array, this will be 0th row and 0 index row. This will be 1 index row. This will be 0 index column. This will be 1 index column. This will be 2 index column. This will be 3 index column. This will be 4 index column. So when I'm talking about array 0, 0, 1, that means take from 0th row and uh, 1 index column. So this will be 2. So 0th row and 1 index column is 2. That means first row, remember first row, second column. And here, second row, fifth column. So second row and fifth column, 1, 2, 3, 4, 5, fifth column. So this is 10, right? So either you can think in terms of index position, or you can think of the real position, index value. So if you think index value, then 1 means this is the one row, and 4 means 0, 1, 2, 3, 4. So 10, right? And if you think from positional aspect, so this is second row and fifth column. So second row and fifth column is 10. So got it? Similarly, how can we access 3D elements? 3D array elements, we need to pass three parameters: row, column, I mean position, and then row, column. So if you create an array like array equal to np dot array, as I mentioned, this is one 2D array, this is second 2D array, and again this 2D array we are putting inside the list. This becomes 3D array. So print array. Now, if I want to print say array 101, okay, 1 0 1 means this is the position of the matrix. So this is zero matrix. This 2D arrow is zero matrix and zero index matrix. This is one index matrix. And then after that, we have row and columns, right? So 1 means this one matrix we are going to consider. And 0 1 means first row, second column. First row, second column value is 8. Similarly, if I put, say, uh, can anyone of you tell me what will be the value for 0 1 2 for this 3D array? What will be the value? Explain the logic also. Hello? Yeah, maybe you can, one of you can unmute and you can tell. Can you hear me all? Hello? Okay. Yes. What will be the answer?
It will be
Is it
6.
5? Sorry, is it 6? Yeah.
Okay. One is saying 5 and one is saying 6. Okay. Let's see. So 0 means zeroth matrix. So this zeroth 2D, and then first 1 comma 2 means second row, third column. So second row, third column, 6. Okay, if we execute it, it's not 5. See, if it is 5, then 2. So remember the index, right? So if I would have put 1 here, that means zeroth matrix, second row, second column. Then it would have given us 5. Got it, right? Whoever said 5 6 does not matter, but let's understand the logic first. Okay, I hope you got it. Okay. Now there is negative indexing, like I had shown last time. There is negative indexing for arrays also. If I'm going to define this 1D array, my array minus 5 will be my fifth last observation. So 1 2 3 4 5. Remember, minus 1 is the last observation and minus n is nth last observation. So what will be minus 5? 1 2 3 4 5 1. Now tell me what will be minus 2, my array minus 2. What will be the value?
7.
Right. You are right. So 7. Then you understood the logic. So if I put minus 5, that means it will be 1. Okay. Now, similarly, negative indexing for array, I mean 2D array is like, say, last element from second dimensional. Okay, array 1 comma minus 1. Okay, this is second last element from second dimension, 1 comma minus 2, and third last element from first dimension is, okay. So let's see how it works. So array 1 comma minus 1 means 1 means second row. One index row is this one, 0 0 index row this one index row this one, and then minus 1. So 10, right? Array 1, that means again this row, minus 2 means second last, so 9. Second last observation from second row. And this is third last observation from first row. Third last observation from first row. 1 2 3. So this is 3. Last one is 3, right? Got it? Okay. Now let's move forward. So slicing means like accessing say range of elements and those things, right? Now suppose we are creating this array 1 2 3 4 5 6 7. Print array 1 is to 5. This means second element till fifth element. Okay, as I told you, this works like close bracket open bracket. So 1 will be included, I mean 1 index will be included, but 5 index won't be included. So it will move forward from 1 index till 4th index. Whatever value are there, it will print it. That's why it's better to remember this side like second index till fifth, I mean second value till fifth value. Okay. So like second value is 2 0 1, so 0 1 index, and then it will move forward 1 2 3 4. That's so basically 0 1 2 3, 4, fourth index. That's why it's going to take 2, 3, 4, 5. Got it?
Yes.
Okay. Now, now similarly, as I explained earlier, like 4 is 2 means fourth index till last value. Fourth index till last value, last index. And this means zeroth index till third index because 4 will be excluded. So better to remember that first value till fourth value. Okay, like this. If we print it, let's understand the logic. So 0, 1, 2, 3, 4. So 4 till last. So the values will be printed is 5, 6, 7 for the 4 is 2 case. And is to 4 case is like 0, 1, 2, 3. So these values will be printed 1, 2, 3, 4. Got it right?
Yes.
Clear? Okay. Okay, I have shown you already. Okay. Similarly, negative slicing also works. How it works? Let's say we are going to create this array 1, 2, 3, 4, 5, 6, 7. Minus 3 till minus 1 means third last observation till last observation. I mean third last observation till last observation, but since I told you that it will be working like close bracket and open bracket, it's going to take till minus 2. So 5, 6. Right? If I would have put say minus 5, that means fifth last observation 1, 2, 3, 4, 5. So this one till this one. So 3, 4, 5, 6. Right? Have you understood the logic? All of you? Right? Yes, in chat box.
Yes.
Okay, good. Okay, now similar to like step value, we can print step value here. Okay, what it will do is it will move to 3 steps. Okay, so 2 is to 6 means it will take values from third position till sixth position, third position till 1, 2, 3, 4, 5, 6, sixth position, and with step 3, that means 3 and then 6 directly, right? If I would have say printed like say 2 steps, and from the first one still, so 0 is to say 6 is to 2. What values will it give? Can anyone of you tell me?
1 and 6.
2, 4,
Oh.
3.
1 and then
6.
see I mentioned 2 step, right? So 1, 3 and then next element.
Oh. 5.
Let's see. Got it right? Because 6th position value won't be considered. Because 5 plus 2 is becoming 7, right? So which is going outside this range. So 7 won't be printed. So 1, 3, 5. You are right. So now let's say okay, how to return all the elements. Okay, like not all the elements, I mean with step 1. So is to 2 means is to 2 means I'm using step 2 for showing all the elements without using this index 0 to 6 and those things. So this is called a blank. Blank means I'm going to take all the elements as is step value 2, and this is going to say like all elements of the array, but is step 3. Let's see how it works. First line step 2, so 1, 3, 5, 7, all values will be printed. Okay, and second thing is 3 steps, so 1, 4 and then 7. Got it? Okay, so far we have covered 1D array slicing. Now let's move forward with 2D array slicing. So 2D array slicing, I need to pass 2 parameters. Okay, remember that in 1D case we are just passing like this 1:4 or 1,4, those things. For 2D array, let's create a 2D array and period array 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10. Print array 1, 1, comma 1:4. Okay, that means second row, and then second value till fourth value. Second row and then second value till fourth value. Let's execute this. So this is first row, this is second row. I mean zero index and one index. So I have mentioned one index. One index is second row. And then I have mentioned 1:4. So 1:4 is 0, 1. So this value one index, two index, three index. Right? So 7, 8, 9. Got it? Now if I would have put say 2:5 and I'll put here 0. What would be the value? Who can tell me?
3, 4, 5.
3, 4, 5, right?
3, 4.
Basically, when you're giving 2:5, right? It starts from third value. So third value till fifth value, right? So third value till fifth value. 1, 2, 3, third value, fourth value, fifth value. And if you consider in terms of index, two index means 0, 1, 2. Two index, then three index, then four index. So 3, 4, 5. Got it? Okay. Now, suppose I want to fetch elements from both the rows. Okay, both the rows. And the, I mean, 0 to 0 to 2 means 0th row also, one row also, and then say so what it does is array 0 to 2. So first of all, it will okay. So let's print it. Okay. So what we are going to do is 0 to 2 means take both the rows and give me the fourth index value. That means fifth value. Okay. So 0 index is this one index is this one. From 0 index, first it will get say fifth value. So fifth value is 5. And from one index or second row, four index value or fifth value will be 10, right? So 5 comma 10, 5, 10. These are the outputs coming from both the rows because I've mentioned to take all the rows and fourth index value, right? Got it, right? What the logic? Okay. Now say from both the rows, I want to have some range of values. So from 0 is to 2, 2 won't be considered. So 0 row as well as one index row. And then give me the values from 1 is to 4. That means second value till fourth value. Second value till fourth value. So second value 2, 3, 4, and 7, 8, 9. That's why it is 2, 3, 4, and 7, 8, 9. Got it, right? Okay.
Avinash,
Now
can you
let's
please, sorry,
yeah, sorry, go ahead.
can you please explain the previous one?
This one, or the
No,
earlier
no,
one? Earlier one.
before that. Yeah,
This
this
one,
one.
right?
Yeah,
Okay.
yeah,
Here,
yeah.
what we are going to do is print array 0 to 2. 0 to 2 means I'm going to take all the rows which are from 0 to 2. And remember that 2 will be excluded because I said open bracket and close bracket. So 0 is to 2 means first row and second row. First row and second row. So first row and second row, both rows are being considered, and take the fourth index value and index 4 value. So what is index 4 value? Index 4 value from first row is 1, 2, 0, 1, 2, 3, 4. Index 4 value is 5. And from the second row, index 4 value is 0, 1, 2, 3, 4, which is 10. So 5 and 10 will be
Okay.
right.
Thank you.
Similarly,
Yep, got it.
similarly, if I give some range like 2 is to 4, that means take third value and fourth value. If I give 1 is to 4 index, that means second value till fourth value. So here we have used 1 is to 4, that means uh, second value till fourth value. That's why second value till fourth value from first row and second value till fourth value of second row is 7, 8, 9. So 2, 3, 4 and 7, 8, 9. Got it, right?
Okay, yeah, thank you.
Right. Now, say numpy data types, there are a lot of data types like I for integer, V for boolean, U for unsigned integer, F for float, C for complex float, right? O for object, S for string, and so on. So what you can do is, so far we have used only numeric elements, okay, integer elements. So if you want to check the D type means uh, data type. Data type, I mean array data type. Okay. So np.array 1 2 3 4. If you print array.dtype, this data type is int 64, integer 64 bit. Okay. Now, like let's create a array containing the strings. We can do that also. If you create array with strings and if you check the d type, this is unsigned, u for unsigned integer. Okay. Sorry, u, this u, the Unicode string, right? Got it, right? Capital U, Unicode string. Obviously, these are strings. That's why the data type will be u6. Now, so let's create a array with defined data type. So I mean, at the time of creating the array, we'll define the type. Basically, ARR equal to np dot array 1 2 3 4, d type equal to s. Okay, and if we print like this, so this will be string, right? Because we have forcefully converted these values to string. Now, say if we want to change the data type to like say integer 4 bytes, right? So int 32. Right. So similarly, if you want to create say float, directly you can create it like np.array 1.1, 2.1, 3.1, and new array equal to array dot as type I. If I put say integer, change it. So what we are going to do is here, initially we are going to use float elements, but later we are going to change the type. Okay, so int is like, that's why it's getting converted. This float values are getting converted to int. So it's the final type is int 32, right? Similarly, so this is I, and similarly you can use int also. If you write I, so this is Python syntax, then you need to put inside quotation, and if you want to put in int is a function, directly you can put without any code. It will work same as above, and the type will be int 64. Okay. Now suppose I have this array 103 and I want to change it to boolean. Boolean means whenever 0 is there, it will be false, and other than 0 elements, it will be true. So for 1, it will be true, for 3, it will be true, and for 0, it will be false. So let's convert array equal to np.array 103, new array equal to array dot as type. This is the formula how to change the type, right? ARR array name dot as type, okay, and then boolean. So print new array and print new array dot d type. If you check it, the values will be new array will be changed from 103 to true, false, true, because the boolean to true, false, true, because we have printed new array and the data type will be boolean. Right? Got it, right? Okay. Now let's say what is copy and view. Okay. So what is copy and view is, like if we create an array like 1 2 3 4 5, if we copy the matrix like say x equal to array dot copy, and let's change some value like array of 0 equal to 42. Once we are copying the element, I mean copying the entire array, array 0, suppose we are going to change some element of array, this won't change the elements of x since we have copied. And if I would have viewed it, so the values will be changing. I'll show you. Wait a bit actually. So see what we are going to do is here. First, we are going to define this array 1 2 3 4 5, and we are storing. I mean, we are making a copy of array and storing it in x. So x equal to array dot copy, right? And now what we are going to do is we are going to change the first element of array. So array 0 equal to 42. So in place of 1, it is becoming 42. But it does not change x. Okay, that's the feature of copy. But this feature will be changing if I use view. Let's see. So array equal to np dot array 1 2 3 4 5, and now we are going to put like x equal to array dot view, right? So now if I change array 0 equal to 42, it will be changing x also. So let's print both array and x. See, initially it changed 42, the first element of array. So 42, 2, 3, 4, 5. But it also changed the values of x. So if you make some changes in array, it will make changes in x automatically. Okay, that's the functionality of view. So that means be careful to use view. So when you want to store the data, I mean, when you do not want to touch the original data, then always use copy, not view. Okay, and if you are working with temporary data, and it does not matter even if it changes the original data also, you can use view. I mean, it's up to you. It's your choice actually, right? Okay, so similarly, let's say we're going to get 1 2 3 4 5 x equal to array dot view, so x0 equal to 31. Now this will be changing both. So 31 2 3 4 5, 31 2 3 4 5. Right? Got it? Okay, so let's move forward. Array equal to np dot array 1 2 3 4 5, x equal to array dot copy. In x we are copying, in y we are viewing, right? But check it. X dot base means the original matrix, and y dot base means original matrix of y. Okay, so let's check it. So basically, in terms of copy, what it does is it does not store the original array in its storage. That's why it's none. So x is copied, right? And for the same reason, if you were changing array elements, this was not changing x, because x does not store the original matrix in its storage, but y stores original matrix in its storage. That's why array dot view, if you check y dot base, the original matrix will be 1 2 3 4 5. This one. Got it, right? So none for copy and the original
What is base
matrix.
here?
Sorry, hello.
Yeah, what is base here? Base.
Your voice is not audible.
Okay, that's okay, fine. I will. What is base? Base
You
x
are,
dot base.
what is
Like,
base?
yeah.
What is base, right? So what is the base matrix? I mean, what is the original matrix? Because we are taking copy from ARR, right? So ARR becomes the original matrix or base matrix, and we are taking view from original matrix ARR. So here also ARR becomes the base matrix. But in case of copy, it does not store the matrix. Okay, it just copies. It does not store the original matrix, which is a base matrix. Base matrix is this one. So for the same reason, if you change some elements of the array, it does not change x. But in case of view, it retains the base matrix. Okay, 1 2 3 4 5. That's why if you change some elements from array, it changes y also. So let's see. Let me show you one thing. So array, say 1 equal to say 50, and then let's say, okay, let's say print x, and let's say print y. So can anyone of you tell me like what will happen?
2 will be replaced with 50, and when we
Your
do
voice is
the,
not low.
yeah, I'm sorry, like I'm not using headphones today. Don't mind.
Okay.
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 So yeah, like the 2 is going to be replaced with 50,
Okay.
and
And then what will be x value? What will be y value?
x, like if we take like x is used as a copy, so it is not going to display anything, but y is going to be displayed as a view. So here we are not using the base, so it is going to, both are going to be displayed like 150 345.
Both, huh? Both x and y. Okay. Let's see. I said that
Oh
x
yeah,
only.
view. Okay.
Yeah.
Y
Yeah. X base is not going to display. Yeah. Perfect.
right?
Yeah.
Got
Yeah.
it?
Yeah.
Got it, right? Now, I don't know who was asking the question. Did you get my point? See, what's happening is,
Yes.
yeah, okay, okay. So what's happening is we are going to change the original array. So base matrix, we are going to change it here itself. Before these statements, we are going to change the base matrix. So base matrix got changed. That's why if you store array, I mean, copy in X and view in Y, and print X dot base, print X dot base is like it is not storing, so it will be none, right? And print Y dot base, this is taking the base matrix. And remember that base matrix, we already changed it. So 1, 5, 150, 3, 4, 5. This is from the output. This 2 is from the output from this. Don't get confused. These two lines are the outputs from these two lines. Print X dot base and Y dot base. And these last two lines are the outputs from X and Y. So X and Y both will get changed because we have changed the original base matrix, right? Got it, right?
Yeah. Yeah.
Okay, so good. Now, okay, now one more logic, like say X equal to 5, and if we put Y equal to X, and if we change Y equal to 10, if we do like Y equal to 10, will it change X?
Below
If
we
I
can see
take
the
Y
result.
X equal to 5, and if we put Y equal to X, if we change the value of Y, will it change the value of X? That's the question.
No.
Let's see. See, if we, so yeah, basically, so this works like copy. Okay, Y equal to X works like copy. So even if you change the value of Y, so X won't be changed. So X value still retained 5. Okay, got it? Now let's move forward with array shape and reshape. This is also important. Okay. So import numpy as np, array equal to np dot array. This is 2D array. So print array dot shape means number of rows and number of columns. See, obviously this is 2 row, 1 row and 2 row, and these are 1, 2, 3, 4, 4 columns, right? So it will be like 2 cross 4 matrix. Like in mathematics, we know like m cross n matrix. This shape is like m cross n. So m equal to 2 here and n equal to 4 here, right? Now let's say we are going to create a 5D array like earlier, 1, 2, 3, 4 elements, and we are going to check the shape. This shape will be, this is interesting, okay? Check this. This is interesting because all the elements will be, I mean, except 4. 4 is, I mean, basically what it does is this is 1, 1, all 1 because one position, then for the second parameter, one position, then one position, and the last will be 4 because this 4 comes from the elements. Like 4, this 4 is from the elements in the columns, right? So these are 4 columns, 1, 2, 3, 4, but rest all will be 4. So 1 comma 1 comma 1, then 4 columns lastly, finally. This is 5D array, right? Now if you want to reshape means changing the shape of a matrix or array. Okay, suppose I'm going to create a 1D array and I want to change the shape to 4 comma 3. That means I want to make it as 2D array, 4 rows and 3 columns. New array equal to array dot reshape 4 comma 3 means 4 rows, and converting this entire list of elements to 2D array and 4 rows and 3 columns. Let's see how it works. Okay, and then I'll explain you. So print object type is like type of matrix, type of array, and then if you want to check dimension, new array dot ndim. If you want to check the shape, new array dot shape. If you want to check the size of the elements, means total number of the elements, new array dot size. And if you want to check the data type of the
Yes,
matrix,
sir.
okay, so new array dot d type, right? Let's print it. First, I had this original list, and remember that it will convert to 4
Yep.
rows, 3 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 rows, 1, 2, 3, 4, 3 columns, 1, 2, 3, 3 columns, right? And check the things like object type is numpy at ND, or a type of array means object of an object type. Object type is numpy.nd array. Dimension new array dot
Two
ending 2. This is 2D array. New array dot shape like row cross column 4 cross 3. New array dot size number of elements which is 12. 12 is like 3 cross 4, or you can calculate manually also 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 9 10 11 12. So 12 elements, right? Which is equal to like row into column 3 cross 4, so 12. And array data type new array dot d type is int64. Got it? So I wanted to show you everything at a place so that you remember. Type is object type. Ending is the dimension of the array. Shape is like shape of the array, row cross column. Size means number of elements. D type means array data type. Whatever data has been stored in the array, what is the type of that data, right? So good. Let's move forward. Like now you want to convert 1D to 3D. Earlier we converted 1D to 2D. Now let's say convert from 1D to 3D. Remember, this value is 2 cross 3 cross 3, and this is 3 into 2 6, 6 into 3 18. So I must have 18 elements in a list 1D array to create this array 2 cross 3. I mean 2 comma 3 comma 3. 2 comma 3 comma 3 means I want to create two 2D arrays and with 3 rows and 3 columns. Let's see. See, two 2D array, right? So this first two is for two 2D arrays. Two arrays. Okay, so two arrays, one array, two array, and then I'm saying that three rows, three columns. So three rows, 3 columns. Got it? And then same as earlier, like type of new array, this thing. So let's see. Class is obviously numpy.nd array, irrespective of the dimension because it's nd array, and ndim equal to 3 because this is 3-dimensional array. And shape will be obviously 2 comma 3 comma 3, whatever we have defined here, because two matrices are two arrays, and then 3 rows 3 columns, so 2 cross 3 cross 3, and total number of elements, if you count it, that will also become 18, and if you multiply this 2 into 3 into 3, that is also 18, so 18. And the array data type is int64, again all int64 elements, right? So now you have learned how to convert 1D array to 2D array and how to convert 1D array to 3D array. Now let's say we do not know the dimension, but still Python will take care of. So let's see how it works. So import numpy as np array equal to np.array 1 2 3 4 5 6 7 8, and I'm going to define like new array equal to array dot reshape 2 comma 2. First two parameters I'm giving, but last I'm not giving. I'm using -1. So -1 we put for unknown dimension. So Python will take care of it automatically. So here remember 1 2 3 4 5 6 7 8. I have 8 elements. So 2 cross 2 already got 4. So what will be the next element? Obviously 2. 2 cross 2 cross 2. Right? That's why if you want to create it, like print it, it gives like two arrays and then 2 rows, 2 columns, because the number of elements coming from number of elements, remember. Okay, got it?
Yes.
Okay. Okay, now say I want to convert a 2D array to 1D array. 2D array to 1D array. What's the syntax? Array dot reshape. If I put -1, this means Python will take care. Okay, so -1 means 1D array. So entire thing is getting converted to 1D array. See, right? Now suppose we are going to create this array and say print array dot reshape 2 comma 4 and print array dot reshape 2 comma 4 dot base. So we want to check whether it is a copy or view. Let's see. So we are going to check. We are going to use reshape, which is converting this base matrix to a 2D array of 2 rows and 4 columns. And then if I want to check the originality, whether originality is lost or not, no, it's not lost. Okay. So the function, whatever you use, it does not change the original data. So original data is still being retained. That's why the base matrix is 1 2 3 4 5 6 8. That means it works like a copy, not view. Got it, right? Got the point?
Yes.
Got the point? Okay. Iterating array remains. Now iterating array remains similar to like loop, you need to access all the elements from the array, and suppose you want to make some conduct some operations and some numerical calculations, algebraic calculations, etc. You can do that. How to do that? Array equal to np dot array 1 2 3. Say for x in array, print x. This is the command for 1D array. For x in array, print x. Let's see how it does. So what it will do is it will check all the elements one by one, and it will keep printing. So first it will keep it will move forward like, okay, 0 index is 1, so it is printing 1. 1 index is 2, so then it will put 2. 2 index is 3, then it will put 3. This is for 1D array. Now let's see, understood, right? Now let's see how to access elements or iterate elements from a 2D array. So for 2D array, we need two parameters, x, y, to check individual elements. Now, if I put only x, what it does is it will print row wise. It will print row wise. So for x in array, print x means first row it will print, then it will move to 0 index row, then it will print 1 index row. And if I want to access individual elements, then I need to pass two parameters, x comma y, x for row and y for position. Let's see how it works. Got it right? Got the difference? Now let's say I want to access individual elements. So for individual elements, for x in array, for y in x, for x in array, for y in x, y in x, because position in that particular row. So suppose this is my 0 row. So first I am storing 0 row and then taking position from 0 row. So what it's going to do is it will stick to first row for this loop, x equal to 0. And then it's going to print all the elements first, 1 2 3. Then it will move to the second row, which is x equal to 1. And then again it will move for all the positions, like it will print 4, it will print 5, it will print 6. Again it will move to x, and x is no more 2. It does not have 3 rows. So it will stop. It will stop executing, and it will come out of the loop. So let's see how to access individual elements. See, it is working as the same logic what I explained. 1 2 3 4 5 6. These three values will come from first row, and these three values will be coming from second row. Got it? Same way, if you want to access a 3D array, let me share how it works. Like array equal to np dot array. This is a 3D array because this is 2D array, and this is again one more 2D array, and we are putting both the 2D arrays in the list. It becomes a 3D array. So for x in array, print of x, what is this x about? This x talks about like first matrix and second matrix. So x equal to 0 means first array, x equal to 1 means second array. Unlike 2D array, because 2D array we had rows, right? Here we had arrays in rows. This is the first row is the first array, second row is second array kind of. So if I print x only, then it gives me this first array and then second array. Now what about if I want to access individual scalars? You need to pass three parameters, x, y, and z. X for array, and y for rows, z for columns, z for position in that row and for that particular array. So like array equal to np dot array, this is the array for x in array, y in x, and z in y. Remember, for x in array, then y in x, because this y is for like row, which row in x, and then z in y, that means position in that row. Finally print z. So how it works is, let me explain the logic. So first for 0, it is going to take this array, and then for y, it is going to take this row, and then for z, it is going to print all 1 2 3 first, and then z will be moving forward. It will move to this row. 4 5 6 will be printed. Then the z task is done, and it will move forward to y again, right? So y will come to this entire array, second array, and then it again. So okay. So basically, once x row is complete, first row is complete, it will move to the second arrow by x, right? And then it will move to y again. It will take the first row of the second array, and then it will move to z, like individual elements 7 8 9, and then it will move to the second row of the second array, and it will print 10, 11, 12. That's how it works. You can get individual scalars. Right? Got it? Any question? Okay, so you can do the same thing using some function without applying this 4 lines. You can use n-deter function. Okay, if you use n-deter function, it will directly give you all the scalars. So what we are going to do is for x in np dot n-deter of array print x. How it works is it breaks all the arrays, all the rows, etc., and it considers individual elements. It's going to print 1, 2, 3, 4, 5, 6, 7, 8. Right? But the same thing you can achieve using an n-deter function. And enumerate means knowing the position of the values or of the array. Suppose I'm going to create a 1D array 1, 2, 3 for idx comma x. Okay, so let me explain you. For loop you can use multiple parameters also. Like here 2 parameters for idx comma x in np.nb enumerate array print idx comma x. What it does is idx means position, 0 index is 1 index is 2, and 3 index is 3. So enumerate is to know the position and the element also. So why this is important? Why enumerate is important? Enumerate is important because when you have a large data set, large array, that time you really do not know like which value is stored at what position, right? So enumerate will help you that time, like where your maximum value is present, where your minimum value is present, those things, where your median value is present, those things you can get it using ND enumerate function. That's why it is important. So now how to do enumerate for 2D arrays? Similar to this one, like only the
Avinash.
yeah, sorry, go ahead. Hello? Yes.
Can you hear me?
Hello, who is this? Your voice is too low actually. Hello?
Yeah, Avinash, can you hear me?
Your voice is too low. I can't hear. Hello? Maybe you can write in chat window.
Yeah, sure. Yeah.
Okay, while you are writing, let me explain this 2D array also because it works in the same fashion. Import numpy as np, array equal to np dot array. This is 2 rows and 4 columns for idx comma x in np dot enumerate array print idx comma x. Right, so it gives like index position of this value, index position of this value, index position of this value, and so on. Remember, this index position is 0, 0 because 0 row and 0 index value, right? This gives 2, 2 means 0, 1, 3 means 0, 2, and so on. 1, 1 means 1, 0 means second row and first column, second row and first column, 5, and so on, right? Okay, so let's stop here for the day and we'll move forward from tomorrow. I have some chat from Prashant, I guess. Let's see.